In this video of our Intro to Robotics series, we're going to learn about motors. We're going to use the Arduino IDE to write code that will run on the robot, and it will allow it to move the motors in such a way that it'll move forward, backward, left, and right. Alright, let's do this. This video is sponsored by PCBWay. They're currently offering 10 pieces of 1 or 2 layer PCBs for $5 with a build time of 24 hours. They have any option you need for your PCBs, and the resulting quality of the boards is great. With friendly staff and great facilities, I highly recommend PCBWay for your PCB manufacturing needs. I'll open up the Arduino IDE and save the file under the name Motors. The way to control the motors on our robot wheelie is by using 4 different pins. 2 of the pins control direction and the other 2 control the speed. 1 direction pin, 1 speed pin control the left motor, and similarly the other 2 pins control the right motor. We'll start by defining 4 variables for the 4 pins with the value of each pin. Next, in the setup function, we'll use the pin mode function to tell the microcontroller that these are output pins. We'll make sure that the names match what we actually defined before. Then we can start defining the functions that we'll use to control both the speed and the direction of those motors. The first one I'll call setSpeed. It will receive 2 values. Each value will control the speed separately of each motor. To make it easier, I'm going to scale the speed values to be in the range 0 to 100 as opposed to 0 to 255, which is the values that the Arduino microcontroller receives. I'll set the minimum to 55 because if I set it to anything lower, the motor will not actually move. Using the analog write function, I can send these values to the speed pins on the Arduino microcontroller. With the function defined, I can go back to the setup function, which is where I'll do all the tasks for this example, and call the function with the values 100, which is the maximum speed. Next, I'll define a function that I'll call moveForward, where I'll set the direction pins to move the motors such that the robot moves forward. To do that, I'll use the digital write function with the value low for both motors. For my test, I just want to do this for half a second. So in the setup function, I'll call the moveForward function and then stop executing any more code for half a second using the delay function. After half a second has passed, I'll need to stop the motors so that the robot doesn't keep moving forever. To do that, I'll define another function that I'll call moveStop. To stop the motors, I'll set the speed to 0, but instead of using our setSpeed function, which always moves the motors, I'll use the analog write function to set the value of each speed pin to 0. I'll also set the direction pins to move forward, and that's used as a precaution. I can execute this new defined function in the setup function, upload the code, and I'm ready to test things out. I'll go ahead and connect wheelie to my USB port. Make sure you follow the steps I described in a different video for how to set up the USB driver so that it can communicate with the wheelie robot. We'll need to select both the board and the port corresponding to the wheelie robot and hit upload on the Arduino IDE. Once the code is uploaded, we can hit the reset button and see it in action. As expected, the robot moves forward for half a second and then stops. For wheelie to move backward, we'll need a similar function that I'll name move backward. We won't need to change the speed of the motors, but we'll indeed need to change the direction from low to high on both motors. We can upload the new code and test it out. After pressing the reset button, wheelie moves forward for half a second and then backwards for half a second and then stops. So the last thing we'll do is make it turn left and right for half a second each. To do that, we'll need two more functions, one that we'll call move left and the other one move right. And instead of setting both direction pins in the same direction, we'll need to set one in one direction so that that wheel spins forward and the other one in the opposite direction so that it spins backwards. In this case, wheelie will turn either clockwise or counterclockwise by what's called differential steering. We can go ahead and upload the code. And after pressing the reset button, as we expected, wheelie moves forward, backward, does a quick turn to the left, and then a quick turn to the right. And there you have it. We've successfully controlled the motors inside wheelie, both for speed and direction, so that it can move forward, backward, turn left, turn right. I encourage you to tinker around with the code, change speeds, make it do a little dance, and have some fun.
If you like my videos, I invite you to my Patreon page where you can chip in a buck or two. That really helps me put in more time into the videos and release them quicker. But whatever you do, don't forget to like, subscribe, or leave me a comment. You can also interact with me on social media. I'm on Instagram, Twitter, and Facebook, and you can even use the community tab of the channel. Thank you for watching my videos, and I will see you next time.